Good afternoon, students. So last class we had started with haloalkanes and haloarenes. So we have seen the introduction, classification, right? So classification we have seen. So today we are going to start with methods of preparation. Okay. So the first method of preparation of haloalkanes. So we are going to see the methods of preparation of haloalkanes. So the first method of preparation is from uh, alcohols from alcohols. So if you take the starting reactant as alcohols, okay, and if you treat it with phosphorus pentachloride. So the first reaction, you can see that alcohol, when it reacts with phosphorus pentachloride, it gives you alkanes. Okay, it gives you what? It gives you alkyl chlorides. Okay, alkyl chlorides plus PoCl3 plus HCl. So this is one reaction wherein you can yield your alkyl halides. Okay, that is haloalkanes from alcohols. Okay, so you can treat it with phosphorus pentachloride. So when you treat it with phosphorus pentachloride, or you can treat it with phosphorus trichloride, you can see the third reaction, right? So if you treat alcohols with phosphorus halides, so especially halides like chlorides, okay, if you take phosphorus chlorides, then it will give you what? It will yield you alkyl halides, okay, plus H3PO3, that is orthophosphoric acid. So this is one reaction. So here X, you can use the halogen as chlorine, bromine, or iodine. Okay, from alcohols. Okay, so you can treat it with phosphorus pentachloride or phosphorus trichloride. So respective halide is obtained. Then the third reaction you can see with thionyl chloride. Thionyl chloride is what? SOCl2. Okay, if you treat it with thionyl chloride, so this is thionyl chloride. So thionyl chloride in the presence of pyridine. Pyridine is a base. Okay, so it is a base. So if you treat it with thionyl chloride in the presence of base, you yield alkyl chloride. Okay, alkyl chloride is obtained because the substituted, this is what substitution is, what your nucleophile is chlorine, right? So if you will get alkyl chloride plus SO2 gas and HCl gas is obtained. So here with alcohols, when you treat it with thionyl chloride, the obtained alkyl chloride which is there, it is the yield will be more. Okay, why the yield will be more? Because easily you can separate them out because SO2 gas, okay, that is sulfur dioxide gas and hydrochloric acid. These both are gas, so they can easily escape out. So these can easily escape out. So this name reaction is called as Darzan reaction. Okay, so what is the name reaction called as? It is called as Darzan's reaction. So if you treat alcohols with thionyl chloride and pyridine, okay, in the presence of base like pyridine, you get alkyl chloride plus SO2 gas and HCl gas is obtained. Okay, so this method is preferred. So this method is very important reaction. Okay, so this method is prepared. Why? Because the two byproducts which are obtained, these are gases. Okay, these are gases and they can be easily removed off. Okay, so these can be easily removed off. So this reaction is preferred most probably. Okay, so we have completed with this. So we'll go for the next reaction. Next reaction is with potassium iodide. So if you treat alcohols with potassium iodide, okay, plus H3PO4, what you obtain? You obtained is iodoalkene. Okay, you obtain iodoalkene. So I've substituted iodoalkene is obtained. So you get H3. So here, so what you're going to do, you're going to treat it with orthophosphoric acid. So here 95% of orthophosphoric acid is taken. So you have to react it with potassium iodide. Alcohols, you can treat it with potassium iodide. Okay, you can treat it with potassium iodide plus 95% of orthophosphoric acid. What you obtained is iodoalkenes. Okay, iodoalkenes is the product which is obtained and water. So this is the reaction. So when alcohols is treated with Ki in the presence of orthophosphoric acid, you obtain iodoalkene. So iodoalkene is the product which is obtained. Okay, so these are iodo substituted. Means what? Ki. So here you can see the nucleophile is I, right? Iodine. So the product obtained will be iodoalkenes only. So this is the preparation. Okay. Then next reaction is with Lucas reagent. Now what is Lucas reagent? If you treat alcohol with Lucas reagent is concentrated HCl plus ZnCl2, anhydrous ZnCl2. What do you mean by anhydrous ZnCl2? Anhydrous ZnCl2 means Anhydrous ZnCl2 means there is no water molecule associated. Okay, there is no water molecules associated. So anhydrous, water is removed from that. The moisture is removed. So if you treat alcohols with concentrated HCl, okay, with concentrated HCl and ZnCl2, that is anhydrous ZnCl2, you obtained what? You obtain alkyl chlorides. You obtain alkyl chloride plus water is the byproduct. So this name reaction is called as Grove's reaction, or it is called as Grove's process. Okay, so alcohols, if you treat it with concentrated HCl and ZnCl2, that is Lucas reagent, you obtain alkyl chlorides plus water. This is Grove reaction. So name reactions are very important. Darzin's reaction, Grove's reaction. Okay, so these are very important name reaction. Now, what is the role here? Yes, what is the role in Grove's reaction? Okay, the function of the ZnCl2. What is the role of this ZnCl2? It weakens this COH bond. It weakens this COH bond, and what is obtained? It is getting substituted. The OH is substituted by Cl. So in Grove's method, what is happening? This ZnCl2 which is there, it is weakening. Okay, it is weakening the bond, that is OH, by Cl. Okay, it weakens the bond. Next is when we see the reactivity of halogens. When we see the reactivity of halogens towards that is the reactivity of halogen towards the reaction with alcohols, HI will be more stronger. Okay, HI, the reactivity of alcohols toward the reaction, that is the HI will be greater than HBr and then HCl. So the reactivity of halogen acid, because you know, how is the arrangement of halogens in group 17? Okay, so fluorine, chlorine, bromine, and iodine. So as you go down the group, what will happen to the size? Size will go on increasing. So as the size increases, what will happen? The effective nuclear charge will be decreasing. Okay, now because the iodine is having larger size, the reaction will be more stronger. Okay, so HI will be more stronger than HBr and then HCl. So the reactivity of halogen acid towards the reaction with alcohol is HI will be greater than HBr and then HCl. The next is the reactivity with alcohols. Okay, the reactivity with alcohols, that is, whenever if you see the reactivity of alcohols, tertiary will be more stable than secondary and then the primary. So tertiary will be more stable and then the secondary and then the primary. So these are the important key points which you need to remember. Okay, so these are the preparation of haloalkanes from alcohols. So with alcohols, you can see the different reagents which we have used. Okay, and we have prepared the alkyl halides. Okay, so next is from alkenes. Alkenes, you know what is alkene now? So if I take this as alkene, okay, CH2 double bond CH2, what is this? This is a symmetrical alkene. Why you can say it is a symmetrical alkene? Across the double bond, if you divide the bond, so the number of carbons are same. It will be CH one here, right? So from alkenes, what will happen here? That is the number of carbon across the double bond is same. So this is called as symmetrical alkene. Now, when you have a symmetrical alkene and if you react it with water, what will be the product? So H2O, it can split up into H plus and OH minus. Okay, so what will be the product? So CH. Okay, now anywhere, what will happen? Anywhere H can add to any of the carbon and OH can be added to any of the carbon because it is a symmetrical carbon. So I can do what? I can add H here and I can add OH here. Okay, so this is a symmetrical. So whenever you have symmetrical, you can add across anywhere. Suppose if I take one more, H2O plus HBr. So HBr is split into H plus and Br minus. So how you will get the product? So CH2, okay, I can add here Br and I can add here H, right? So this is the product option. So whenever you have a symmetrical alkene, it can add up anywhere. Now suppose if I have an unsymmetrical alkene. What do you mean by unsymmetrical alkene? Unsymmetrical alkene means now across a double bond, the number of, if I divide this, the number of carbon atoms are not same. Okay, the number of carbon atoms are not same. Here there are 1, 2, here there is 1. So thus it is called as unsymmetrical alkene. So whenever you have an unsymmetrical alkene, then how you will add it? Okay, how the addition will takes place. So now we are going to prepare alkyl halides from alkene. Okay, so when we are going to prepare in this condition, the alkenes which you are going to prepare alkyl halides from alkenes. Okay, Now this alkenes will be unsymmetrical alkenes. Okay, we are going to prepare it from unsymmetrical alkene. Now what do you mean by unsymmetrical alkene? I have just explained you. Now so whenever you have an unsymmetrical alkene, the addition will take or it will follow Markonikov rule. Now what is Markonikov's rule? Markonikov rule states that whenever you have unsymmetrical alkene, the addition of okay, now addition of hydrogen halide. Right? This is a addition of a hydrogen halide. So addition will takes place in such a way that the negative part of the carbon, okay, negative part of the carbon will be added. Sorry, negative part of the hydrogen halide, okay, will be added to the carbon which will have less number of hydrogen atoms. Okay, so this is Markonikov rule. So what is Markonikov rule? The negative part of the alkyl halide will be added to the carbon which has less number of hydrogen atoms. Now between these two, which is having less number of hydrogen atom, this, right? So this is Markonikov rule. So CH, this will be negative part will be added here and this will be CH3. So this is Markonikov rule. Now this is Markonikov. Now, what do you mean by anti-Markonikov rule? Anti-Markonikov rule will be reverse of this. Suppose I have CH3, CH double bond CH2. Okay. And I'm going to add the hydrogen halide. So if it is written peroxide. Okay. If it is written peroxide means what? It will undergo. If you write peroxide means it is following anti-Markonikov rule. Now, what is anti-Markonikov rule? It is reverse of that. So what will happen? So negative part of the hydrogen halide will be added to the carbon which will have more number of hydrogen atom. So it will be CH3, CH2, CH2, Br. Okay. So the negative part of the hydrogen halide will be added to the carbon which will have more number of hydrogen atoms. So this is anti-Markonikov rule. So whenever you have unsymmetrical alkene, okay, if there is no peroxide written, okay, then it is following Markonikov rule. If there is peroxide written or any peroxide is given, Na2O2, H2O2, any benzoyl peroxide, okay, if any peroxide is given, that means it is following anti-Markonikov rule. In this also the product obtained will be like this, CH2, CH2, Br. This also product is obtained. But here in Markonikov rule, this will be major product, this will be minor product. Okay, and in this anti-Markonikov rule, this will be major product and this product is also obtained, that is CH, Br and CH3. But this will be a minor product. Okay, so this will be a minor product. So this is from alkenes. Next we are going to see is halide exchange method. Now what do you mean by halide exchange method? In halide exchange method, first is the Finkelstein reaction. Okay, first is what? Finkelstein reaction. So what you are going to do in Finkelstein reaction? We are going to form iodoalkane. So this is a reaction wherein you are forming iodoalkane. So what is happening here? Alkyl chlorides is treated with sodium iodide. Okay, alkyl chlorides is treated with what? Alkyl chlorides is treated with sodium iodide in the presence of dry acetone. It is in the presence of dry acetone and you yield what? You will yield iodoalkanes. You yield what? You yield iodoalkanes and NaCl is the byproduct which is obtained. So Finkelstein reaction wherein you can form what? You can prepare iodoalkanes. You can prepare their iodoalkanes. Okay, so the Finkelstein reaction is best reaction for preparing your iodoalkanes. So what is the starting product? This is exchange method, means what? Chlorine is being replaced by iodo group. Okay, so it is called as the exchange method. Halide, only the halides are getting exchanged, right? The halides are getting exchanged, so it is called as halide exchange method. Now, next which we are going to see is Schwartz reaction. Okay, what do you mean by Schwartz reaction now? In Schwartz reaction, this is also an example of hydrogen halide method. Here, what is happening? Here, alkyl chlorides or alkyl bromides. Okay, alkyl chlorides or alkyl bromides, they are heated with metallic fluorides. Okay, they are heated with metallic fluorides. They are heated with metallic fluorides such as AgF. Okay, then Hg2F2, then COF2, SbF2. Okay, so from this you can form alkyl fluorides. So from this you can obtain alkyl fluoride. So what is happening? Alkyl fluorides is treated with metallic, it is heated with metallic fluorides to obtain alkyl fluorides. Okay, so this is known as Schwarz reaction. So Finkelstein reaction, best reaction for preparing iodoalkanes. Schwarz reaction is the best reaction for preparing fluorides. Okay, so these are the two halide exchange methods. So next, so last time we have solved this. Okay, so we'll go for the MCQs based on okay, so we are going to see the MCQs based on now methods of preparation. So from amongst the following alcohols, the one that would react fastest with concentrated HCl and anhydrous ZnCl2 is A. Methylpropanol, B. 1-butanol, C. 2-butanol, D. 2-methylpropane-2-ol. From among the following alcohols, which will react fast with concentrated HCl and anhydrous ZnCl2. What is concentrated HCl and anhydrous ZnCl2? What is this reagent? Concentrated HCl and anhydrous ZnCl2. Which is this reagent? So it is a Lucas reagent, right? As we have discussed, it is a Lucas reagent. So anhydrous, anhydrous ZnCl2 and concentrated HCl, it is Lucas reagent. Okay. So when we had discussed about the alcohol, so how is the reactivity of alcohols? Reactivity of alcohols is tertiary will be more stable, then secondary, and then primary. Okay, tertiary is more stable than secondary and primary. So now what we have to see is which is the tertiary among the following. Okay, so 4 options are given. So you have to tell which is the tertiary among the following. So which is the tertiary? So 2-methylpropanol. Okay, how is the structure of 2-methylpropanol? Right, 2-methyl propanol. Okay, 2-methyl and this is propanol. Okay, this is so this is what? This is a primary, right? This is a primary alcohol. Then 1-butanol, CH3, CH2, 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 OH. Right, this is what? This is 1-butanol. So 1-butanol, this is also a primary, right? So this is also primary. Then 2-butanol. 2-butanol is CH3, CH2, CH2. Okay. So CH3, CH2, CH2, and CH2. So this is what? So this is secondary alcohol. Okay, this is a secondary alcohol. This is a secondary alcohol. Then the last one, D option, 2-methylpropane-2-ol. So 2-methylpropane-2-ol, CH3, CH2. So this is at second position you have. Okay, so this is 2-methylpropane-2-ol. So 1, 2, 3. So at second position you have methyl, second position you have all. So this is what? This is a tertiary alcohol. So fourth is the correct answer. Right, understood? So when we are seeing the reactivity of alcohols, what will happen? The tertiary will be more stable, then secondary, and then the primary. Okay, so this is the reactivity series. So this is primary, this is primary. The third option is it is secondary, and this is tertiary. Understood? I hope it is clear. Yes. So we'll go for the next question. Next MCQ. The name of the product obtained by addition of HI to propene in the presence of peroxide catalyst is A, 1-idopropane, B, 2-idopropane, C, 1-idopropene, D, 2-idopropene. The name of the product which is obtained by addition of HI to propene. So how is the structure of propene? CH3, CH double bond, CH2. What? Plus HI. We are going to add a hydrogen halide. They have said in the presence of peroxide. So when you have peroxide means what? It is Antimarkoniov rule, right? It is following Antimarkoniov rule. So how it is? Negative part will be added or to the carbon which is having more number of hydrogen atoms. So it will be CH3, CH2, CH2I. So what is the answer? It will be 1-idopropane. Okay, 1-idopropane. So A will be the correct answer. 1-idopropane. So the name of the product which is obtained by addition of HI to propene in the presence of peroxide. So if it was not peroxide, then it would be what? It would be Markonikov rule. The best method for conversion of an alcohol into an alkyl chloride is by treating the alcohol with A, PCl3, B, PCl5, C, thionyl chloride in the presence of pyridine, and D, dry HCl in the presence of anhydrous ZnCl2. So best method of converting alcohols, okay, alcohols to alkyl chloride. So which is the best method for treating alcohols to alkyl chloride? So if you treat the alcohols with thionyl chloride in the presence of if you treat thionyl chloride in the presence of pyridine, okay, then what you will obtain? You will obtain alkyl chlorides, because the byproducts which are obtained is SO2 gas and HCl. Okay, so these are gas. So these will be easily liberated. So the best method will be while treating the alcohol with thionyl chloride in the presence of pyridine. Okay, so C is the correct answer. So we'll go for the next one. Ethyl bromide is industrially prepared from. So how you can prepare ethyl bromide? How you can prepare ethyl bromide? So if you treat alcohol, if I take ethyl alcohol plus HBr, okay, if I treat ethyl alcohol and HBr, and if I treat it with concentrated H2SO4, okay, if I reflux it, you get C2H5Br. That is ethyl bromide is obtained plus water is obtained. Okay, so ethyl bromide, when it is industrially prepared by refluxing the alcohol, okay, you can what you can do by treating it with concentrated sulfuric acid, you can obtain. So it is C option. So industrially at the commercial, at the more commercial this, you can obtain it from alcohols. You can treat it with HBr, okay, and a little amount of concentrated H2SO4, okay, that is acid. So it will provide protonation. So it will undergo protonation and you will obtain ethyl bromide. So industrially you can prepare by this method. So next question, ethyl chloride on reduction with lithium aluminum hydride gives compound X as important product. X on chlorination with 1 mole of Cl2 in the presence of light at ordinary temperature gives Y. What is Y? So you have to tell what is Y. So we'll go stepwise. Okay. Ethyl chloride. So ethyl chloride, how it will be? Ethyl chloride C2H5Cl. So if you treat ethyl chloride, what you have to do? You have to do reduction. Reduction means what? Removal of hydrogen. Addition of hydrogen. Okay, addition of hydrogen. How it will be? Addition of hydrogen in the presence of lithium aluminum hydride. Okay, so ethyl chloride if you treat it with that is hydrogen, okay, that is if you are adding hydrogen, that is it is undergoing lithium aluminum hydride, it is a good reducing agent. So if you have to add this, so what will be the product? It will be C2H6. Okay, C2H6. This is your X product. Okay, now this you have to further do what? This will give you X as important product. Now this X will be chlorination. You will undergo chlorination. It will further undergo chlorination in the presence of chlorination will be in the presence of light. Okay. So this will give what? What will happen now? Again, this H will be replaced. One of the H will be replaced by Cl. So this is the, so 1 mole of Cl2 in the presence of light will give you Y. So Y is what? It is C2H5Cl. So option C is the correct answer. So next question, what is A? What is A in the following reaction? Okay, so this is a reaction. What is given? This is a alkene. You can see this is alkene. This is an unsymmetrical alkene, and this is a hydrogen halide. Okay, what is the obtained? Now there is no peroxide. So this is following what? It is Markonikov rule. So what is according to Markonikov rule? The negative part of the halogen halide will be added to the carbon which is having least number of So what will happen? The negative part of the halogen halide will be added to the carbon which is having least number of hydrogens. So you have to just see this. Don't see the big molecule. You can just look at this. So it will be CH2, then this will be CH, okay, Cl and CH3. So which is our correct answer? Just see at the options. It will be option number C. Okay, it will be option number C. So Markonikov rule, the negative part of the halogen acid will be added to the carbon with the least number of hydrogens. Okay, so I hope this is clear. So these are all methods of preparation which we are solving. So next we are going to see with the nucleophilic substitution reaction. Okay, so what do you mean by nucleophilic substitution reaction? Yes, what do you mean by nucleophilic substitution reaction? So in nucleophilic substitution reaction, what is happening? The nucleophile. Okay, suppose there is a if there is a alkyl halide, okay, if you attack, now what will happen? The nucleophile will attack this substrate. Okay, so in alkyl halide, the CX bond. Okay, so you know that the CX bond is a polar bond. Why? It is due to minus I effect. Okay, minus I effect of the electronegative atom. So this positively charged carbon, it will be easily attacked. So when this, what will happen? As this is a polar bond, this when it breaks, okay, this will have a negative charge and this will have a positive charge. So when it carbon has a positive charge, the nucleophile can easily attack at this particular carbon. And what will happen? Easily attacked by the nucleophile and substitutes this halogen atom. So the product obtained will be CuNuC, okay, plus X minus. Okay, so this is the product of it. So this is a nucleophilic substitution reaction. So nucleophile can be easily substituted. Okay, so because of this polar bond, X bond, okay, the halogen atom will leave with its pair of electron. The carbon will be left with a positively charged, and this can be easily attacked by the nucleophile. So the nucleophile will get substituted, okay, by the halogen. So this is nucleophilic substitution reaction. So now based on the different types of, so our starting reactant is alkyl halide. So these are the different reagents or these are the different reagents which can produce nucleophiles. Okay, these are the different reagents which produces nucleophiles. So first is with aqueous NaOH or KOH. So this is a base. Okay, aqueous NaOH or KOH is a base. So what is happening? The X, that is a halide group, is being halide group is been replaced by OH group. So what is that? The nucleophile which is produced here is OH minus. Okay, so the X. So what is here? RX plus. OH plus NaX. Okay, so this is our reaction. So this is a nucleophilic substitution reaction. So alkyl halide is treated with sodium hydroxide. So this is the nucleophile and it is replaced. So this is a nucleophilic substitution reaction. Second is sodium alkoxide. So this is sodium alkoxide. So sodium alkoxide, it will produce R. Okay, R dash. So the obtained reaction product will be ROR dash. Okay, it is ROR dash. ROR dash is what? ROR dash means it is a ether. Okay, it is ether. So it is called as Williamson ether synthesis. So this type of name reaction is called as what? It is called as Williamson ether synthesis. And this byproduct obtained is NaX. The byproduct which is obtained is NaX. Okay. So alkyl halide, when it is treated with sodium alkoxide, it gives you ether. Okay, it gives you ether and NaX. That is a byproduct obtained is sodium X. So this is another nucleophilic substitution reaction. Next is alkyl halide when you treat it with KCN, that is potassium cyanide. The nucleophile will be Cn minus. Okay, nucleophile will be Cn minus and it obtain alkyl cyanides or it is called as nitriles. What it is called as alkyl cyanides or it is called as nitrite. Then alkyl halides, if you treat it with AgCN, okay, if you treat it with AgCN, the obtained product will be NC. Okay, RNC. What is this RNC? These are called as isocyanates. These are called as isocyanates. Okay, remember this. Remember this, very important. So what happens when you treat it with KCN? Okay, it forms alkyl cyanides as a main product, and when you treat it with AgCN, it forms isocyanate as the main product. So what is the reason here? Yes, what is the reason? So the reason is that KCN. So when you are seeing KCN, KCN is ionic in nature. Okay, KCN is ionic in nature, and therefore both carbon and nitrogen are free to link with the alkyl halides. So these are very free to link with the alkyl halides, since the CC bond here is stable, okay, as compared to CN bond. So it links with the carbon. So here what happens? CC bond will be linked. So, okay, and it will form alkyl cyanide as the main product because KCN is the ionic bond. Then when you are seeing AgCN, okay, AgCN, it is covalent in nature, and here only nitrogen is available for linking. Okay, in this case, only nitrogen is available for linking. Hence, what is formed is isocyanates. That is, alkyl isocyanates are formed. Okay, so these are the another set of nucleophilic substitution reaction. Next is when alkyl halides are treated with AgNO2. Okay, that is silver nitrate. It forms what? Nitroalkanes are obtained. The nucleophilic product will be nitroalkanes plus AgX. Then the next reaction is when it is treated with potassium nitrate. Okay, when it is treated with potassium nitrate, you obtain alkyl nitrite. What you obtained is alkyl nitrite plus KX is obtained. So this is nucleophilic substitution reaction. So these are some of the reagents from which nucleophiles are produced, and you get a nucleophilic substituted products. So some more. So if you treat with alkyl halide with RCOOAg, okay, what is obtained is esters are obtained. Esters is what? R C double bond O R dash. Okay, so these are esters. So this linkage is called as ester linkage. Okay, so plus AgX is obtained. Then when you treat alkyl halides with lithium aluminum hydride, what is lithium aluminum hydride? Lithium aluminum hydride is a reducing agent. It is a good reducing agent. So it forms what? It forms alkanes. It forms alkanes. Then if you treat alkyl halides with R lithium, if you treat alkyl halides with R lithium, you obtain alkanes. Okay, alkanes are obtained. So these are all substituted products. Then alkyl halides, when you treat it with ammonia, what is happening here? One of the hydrogen is replacing by the alkyl group. So your first primary alkyl is treated, amine is formed. Again, if you treat with excess of ammonia, what happens? One more hydrogen has been replaced by alkyl group. Further, if you treat with excess of ammonia, what is happening? Again, one hydrogen is replaced by alkyl group. Okay, and lastly, it forms quaternary ammonium salt. So these are the reactions. Okay, so these are very important reactions. So you need to remember the reagents and what type of nucleophile is being produced. So based on this, we'll solve some questions. So which of the following alkyl halide is used as methylating agent? So which can be used as a methylating agent? Which reagent? Methylating agent. How you can produce the methylating agent? Which is the so methylating agent, you know that when you see the reactivity of halogen acids, okay, you know that iodo, right? Iodo will be this, then Br, and then is your Cl. So your iodo, so it will be methyl iodide. Okay. So the reactivity of halogen acids, we have seen that are uh, iodo, then Br, and then is the Cl. Okay, so it will be methyl iodide. So methyl iodide is used for methylating agent. Then ethyl chloride. So if you treat ethyl chloride, what is the structure of ethyl chloride? C2H5Cl. If you treat it with AgCN, okay, if you treat it with AgCN and if you heat it, it forms a compound X. Now, what is this compound X? When you treat it with AgCN, which is a reactive, it will be N. So it will be C2H5NC. It will be C2H5NC. Okay. So C2H5NC. So which is the correct answer? It will be A. So isocyanate is formed. So when you treat with AgCN, it is a covalent bond. Only nitrogen is available for linking. When you treat it with KCN, as it is ionic, both carbon and nitrogen is available, but carbon-carbon bond will be more stable than carbon-nitrogen bond. So it will form CN bond. Okay, RCN bond, that is cyanides are formed. So here isocyanates is formed because AgCN is there. Next one, what are the reagents and reaction condition used for converting ethyl chloride to ethyl nitrate? So which are the reagent conditions? So when you want to treat, convert your ethyl chloride. Ethyl chloride is C2H5Cl to ethyl nitrate. It is C2H5 ethyl nitrite. Okay. So what is the reaction condition? You require KNO2 plus ethyl alcohol, water, and heating condition. Okay. So when you have nitrate, potassium nitrate as the reagent, so it can produce nitrate as the ions. Okay. So this is a diazotization. So this is not used. This is a diazotization reaction. KCN. So if you use KCN, again it will yield what? It will yield isocyanate. So this is also wrong. Then when you use AgNO2, AgNO2 is not used. Okay. If you so it will not produce nitrate ion in this condition. So what is the reagent and the reaction condition used for reacting? It will be option A. So option A is the reaction condition which we can use for converting our ethyl chloride to ethyl nitrite. So elimination reaction. So next we are going to see with the elimination reaction. What are elimination reaction? So alkyl halides, they undergo beta elimination reaction in the presence of alcoholic KOH. Okay, alcoholic KOH to yield alkenes. Beta elimination means from the beta carbon, there will be removal of hydrogen. Okay, so this type of reaction is also called as beta elimination or hydrohalogenation, dehydrohalogenation. What do you mean by dehydrohalogenation? Dehydrohalogenation means there will be removal of one hydrogen and one halide group. Okay, dehydrohalogenation means one hydrogen and one halide group is removed. So now you can see here, I'll will go with the example. So this is one bromoethane, one bromoethane. So nearer to the halide group. So this is alpha carbon, this is beta carbon, this is gamma carbon. So what is done here? It is treated with alcoholic KOH. Alcoholic KOH, alcoholic, okay, if you treat it with alcoholic KOH, what is happening here? Okay, so I've just have written it. So what is happening? So one hydrogen and one halide group will be eliminated to give you the product as CH double bond CH3. Understood? So this is a beta elimination. So from the beta carbon, what is happening? From the beta carbon, your hydrogen, and from this carbon, your halogen will be removed. So this is called as beta elimination. Okay. So so if you have unsymmetrical alkene, so if you have an unsymmetrical alkyl halides, then that time the elimination will follow Setzef rule. What type rule it will follow? It will follow Setzef rule. So according to the rule, what is the rule says that the hydrogen will be eliminated preferentially from the carbon atom which has less number of hydrogen atoms, and thus highly substituted alkenes is the major product. Okay, so whenever you have an unsymmetrical alkyl halide, what is happening here? The hydrogen will be eliminated from the carbon atom which has less number of hydrogens. Okay, and the product will obtained will be highly substituted alkene. So we will see the example, then only you will come to know. So this is an example. So this is what you can see. Now this is a bromoatin halogen atom. So this is alpha, this is beta, this is also beta. So when you have more than two alkyl halides, right? The substitute you can see. So from where the hydrogen will be removed? The hydrogen, what is the role? Just see, right? So the preferentially the hydrogen will be eliminated from what? It will be eliminated from the carbon atom which has less number of hydrogen atoms, right? So just see now, just apply the rule. So from which it will be eliminated? From this carbon. From this carbon it will be eliminated and it will form highly substituted product. So CH double bond CH and CH3. So this is 80%. The yield will be 80% and this will be 20%. So this is Setzef rule. Okay, this is Setzef rule. So the order of reactivity of alkyl halide towards the dehydrohalogenation will be tertiary, will be more stable than secondary and then the primary. So this is the reactivity condition. Okay. And what is the question? Just remember one. So which is the reagent used for dehydrohalogenation? So it is okay. So the order of reactivity of alkyl halides towards the dehydrohalogenation will be tertiary, will be more stable than secondary and then the primary. Okay. So this is the reaction condition. Okay. So the MCQs based on elimination reaction and Setzef rule, we shall see in the next class. Okay. So today's class, we have discussed about the methods of preparation. Then we have seen nucleophilic substitution reaction, how the alkyl halides are reacting with different reagents, how the reagents which nucleophiles are produced, right? So we have seen the different reaction. Then we have seen the elimination reaction, okay, and Setzef rule. So based on this, the MCQs I shall discuss in the next class. So thank you, dear students. So we will meet in the next